In this module, we can discuss the concept of entropy and its properties. In the last module, we have discussed the concept of information and the average information umbrella source is called as source entropy. Here, for deriving the expression for entropy, let us assume there are m number of messages. Let us assume m number of messages, capital M, that range from M1 to MM. These messages with respect to probabilities as P1 to PM. These are transmitted through the channel. Here capital M represents the total number of messages. Now, for example, we are transmitting a particular length of sequence, length of bit sequence capital L. Out of that, these messages M1 to MM are repeated. That means the probability of occurrence of M1 message out of capital L number of messages is P1 into capital L. Therefore, the information content due to the message M1 is I of M1 is equal to P1 into L into log 1 by P1, because information of a particular message is proportional to its 1 by P1, and it is equal to log 1 by P1. Here, the probability of occurrence of M1 message out of L number of messages is P1 into L. That means M1 is repeated throughout the length sequence L with a probability of P1 into L. So P1 into L into log 1 by P1 is the information of M1 for a length of L sequence. Similarly, the probability of occurrence of M2 message out of L number of messages is P2 into L. Actual probability is P2. Out of L we are evaluating. So P2 into L is the probability of occurrence of M2 message out of L number of messages. Therefore, the information content of M2 out of L number of messages is I of M2 is equal to P2 into L into log 1 by P2. Similarly, if we extend the same to the mth message, small m suffix capital M is I of mm is equal to Pm into L log 1 by Pm. But we know that the total information I suffix t is the sum of information contents due to m number of messages. So I suffix t can be written as I of m1 plus I of m2 plus so on I of mm. We know that I of m1 is P1t into L into log 1 by P1. Similarly, substitute I of m2, that is P2 into L into log 1 by P2. Similarly, substitute I of mm, that is Pm into L into log 1 by Pm. If you take L as common, L into P1 into log 1 by P1 plus P2 into log 1 by P2, so on Pm into log 1 by Pm. But we know that entropy is nothing but the average information content. So we can write entropy by L. So if you take L as common, so here if you take L as common and take it to the LHS, then H can be written as IT by L. So IT by L will be P1 log 1 by P1 plus P2 log 1 by P2, so on Pm into log 1 by Pm. This is nothing but a summation series. So we can write it as summation some variable j is equal to 1 to m p suffix j into log 1 by p suffix j. We know that the units of information are bits when the base of the logarithm is 2. Here, similar in the same manner, entropy units entropy units of entropy is bits per message, because here we are transmitting the message. For example, if you are transmitting the symbols, the units will be bits per symbol. Similarly, bits per any element, that may be sample or symbol, whatever may be, the units are bits per element. When the base of the logarithm is 2. So finally, the expression for entropy is minus summation j is equal to 1 to m p suffix j log p suffix j base 2, where p suffix j is the probability of the respective message. Let us move to the properties of entropy. So first property is if a data stream consists of only one message. So here we are assuming that if a data stream has only one message with maximum probability P1 is equal to 1, then the entropy is 0. Because the entropy expression is H is equal to minus summation J is equal to 1 to M P suffix J log P suffix J base 2. But here they told that in the property only one message exists. So let us assume only J is equal to 1 exists. So minus P1 into log P1 base 2 will be our entropy. And here they mentioned that P1 is equal to 1. So 1 log 1 base 2. So log 1 is 0 and 0 multiplied by anything will be 0. So finally, first property is proof is done. So coming to the second property, if a data stream consists of multiple messages, but out of them, if only one message has maximum probability equal to 1, and if other properties are 0, then also our entropy is 0. So H is equal to minus summation J is equal to 1 to M, P suffix J log P suffix J base 2. So here there are capital M number of messages at a issue. So minus 1 log 1 base 2, minus 0 log 0 base 2, minus 0 log 0 base 2, like that up to M number of messages, the probability P suffix J log P suffix J is 0. Because only one message has probability as 1. So here 0 multiplied by anything is 0. And in the first uh, summation, in the first parameter, that is in the first term, if you see log 0 multiplied by anything is 0. So in this case also entropy is 0. And third property is entropy of a particular event is always greater than or equal to 0. So entropy is the minimum value of entropy is 0, which we studied in the properties 1 and 2. In the previous slide we discussed. So H of E is always greater than or equal to 0 with a minimum value as 0. So coming to the fourth property, let us consider a binary symbol having two messages, only two messages, that is M1 and M2. Let us assume their respective probabilities as P1 and P2. Then the entropy H is equal to P1 log 1 by P1 plus P2 log 1 by P2. So base 2. So H can be written as minus P1 log P1 base 2 minus P2 log P2 base 2. For example, in general, we know that the sum of the two probabilities, sum of the even probabilities is equal to 1. So P1 plus P2 is equal to 1. For example, if P1 is equal to some P, P2 will be 1 minus P. So just to substitute the P1 as P and P2 as 1 minus P in the above expression. Then H can be written as minus P log minus of P log P base 2 plus 1 minus P log 1 minus P base 2. So this is the entropy when we have two messages. So in that case, when the two messages has equal probability, that is for equally likely messages, let us move to the fifth property. Maximum entropy of the event with two equally likely messages is 1. That occurs at P is equal to 1 by 2. So this property is an extension of fourth property. But the only difference is here we are considering equally likely messages. So equally likely messages mean that the probabilities are, their respective probabilities are same. So P1 is equal to P2 is equal to P. But P1 plus P2 is 1. So P will be 1 by 2. So P1 is equal to P2 is equal to 1 by 2. Just substitute in the expression of entropy. Then you will get minus of log 0.5 base 2. So 0.5 can be written as 1 by 2 or 2 power minus 1. If it in log, if for the logarithmic function log x power y, you can write it as y log x. So take this minus 1 here. So log 2 base 2 will be 1. So minus of minus 1 will be 1. So fifth property is maximum entropy of a event with two equally likely messages is 1, and that occurs at P is equal to 1 by 2. In this plot also you can see. So when probability for two equally likely messages, when P is equal to 1 by 2, you are getting maximum entropy equal to 1. And sixth property is maximum entropy for m equally likely messages. So this fifth property. In fifth property, we have considered only two messages, and in sixth property, we have considered capital M messages. Equally likely, M capital M number of messages we considered, and we are going to derive the maximum entropy, and that usually occurs at P is equal to 1 by M, because sum of all the event probabilities will be 1. So P1 plus P2 plus P3 plus so on Pm will be 1. Therefore, if the sum of all the probabilities is 1 and all the probabilities are equal, then you can equate it as P1 is equal to P2 is equal to P3 is equal to so on 1 by M. So, but entropy for a capital M number of messages is represented as H is equal to P1 log 1 by P1 plus P2 log 1 by P2 so on Pm log 1 by Pm. But please substitute all the properties as 1 by M. So if you substitute, you can see all the terms are equal. So these terms are repeated M, capital M number of times. So 1 by M into log M. So M gets cancelled here. So you will get maximum entropy as log M base 2. So maximum entropy of capital M equally likely messages occurs at 1 by M. And that magnitude is equal to log M base 2 bits per message. And as you move from 1 by M probability, the entropy gradually reduces to 0. So in this module, we have discussed the concept of entropy as well as its properties.